Hi there, this is Penelope. This is Penelope from WellTech, and this is a short video looking at the rules of algebra, and it's the first video in a series of videos on basic algebra skills. The rules of arithmetic that we've looked at before in the previous playlist also apply to any old number, and we learned that, but what it also applies to is where we use variables instead of numbers. Now, a variable is just a letter, or it might even be a symbol like that. It's just what we're using in place of a letter. So the rules, in place of a number, so that the rules that work for numbers also work for these things, variables. Okay, let's look at commutativity. We've looked at this in terms of numbers. Two numbers can be added or multiplied in any order without affecting the result. So here, when we're talking algebra, x plus y is going to be the same as y plus x, and x times y is going to be the same as y times x. Now, we need to be careful that x minus y is not equal to y minus x, and nor is x divided by y equal to y divided by x. Now, there are a couple of things that it may be true. X minus y is not equal to y minus x unless x is equal to y, and then it would be true. And for x divided by y to be actually equal to y divided by x unless x was equal to y, and neither of them is 0. So these are just sort of special cases, and we don't really need to worry about those. So yes, addition is commutative, and yes, multiplication is commutative. We've looked at associativity when we looked at numbers. It's the way they're associated under addition or multiplication. Now let's look at it in algebraic terms. So x plus y plus z is the same as x plus y with a bracket plus z, or indeed x plus y plus z with no brackets. Similarly, x times y times z, bracketed like that, is exactly the same as if we regroup them like that, or forget about the brackets altogether. Now, if we're talking about subtraction and division, associativity does change the result. So let's have a look. X minus y minus z is not the same as x minus y minus z unless z is 0. And similarly, x divided by, and associate them that way, that's not equal to x divided by y divided by z unless z is 1 and at the same time y is not 0. So again, these are special cases, but for most part it's not true. It's fine for addition, fine for multiplication, but it's not fine for subtraction, and it's not fine for division. Then we look at the third rule. Now the third rule, if you remember, needs two operations. It needs addition and multiplication. So let's have a look here. So if we go x times y plus z, that's equal to x times y. So the multiplication is distributed over the addition plus xz. And also, if we had x plus y, so we're going the other way, and the z is at the end, that is equal to xz plus yz. Now, let's have a look at division. Division goes one way, but not the other way. Let's have x plus y, bracket that, divided by z. That is equal to x divided by z plus y divided by z. So that's true. But if we go the other way and go x divided by y plus z, that's not the same as x divided by y plus x divided by z. So that's one you need to look out for. In other words, what we've got here is, say, x plus y over z, that's just writing it a different way, is equal to x over z plus y over z. But, and this is something you need to remember, x over y plus z is not equal to x over y plus x over z. So just look out for those.